All right, hey there. This is going to be a video review for Chapter 6 and Chapter 7 for your final, okay? We're starting with Chapter 7. Here's the sequences. Chapter 6, you might not have the actual copy of the paper. And if I'm a little energized, it's because this is like my third take because I kept messing up. So after this, I'm not stopping to fix my mistakes. I'm just going to move forward. Anyway, first thing you do when you put in the first six terms, you plug in one, you plug in two, you plug in three. Guess what? You plug in four, plug in five, plug in six. In this scenario, though, if you notice the pattern, -1, -5, -9, use that to your advantage. I'm going down by four, so -13, -17, -21. Over here, it's 3, 9. 3 to the first power is 3. 3 to the second power is 9. 3 to the third power is 27. Guess what? 3 to the fourth power is 81. 81 times 3, or 3 to the third, whatever, power is 243. And then times that by 3 again, that's going to be 729. That's 3 to the sixth power. That's 3 to the fifth power. Over here, it's n squared plus 5. So 1 squared plus 5 is 6. And 2 squared plus 5, that's 4 plus 5, is 9. And then 3 squared plus 5, that's 9 plus 5, that's 14. And 4 squared plus 5, or 16 plus 5, that's going to be 21. If you notice the pattern here, it goes up by 3, then goes up by 5, then goes up by 7. So the next one should go up by 9, so that's going to be 30. And the next one after that should be going up by 11, so that's going to be 41. All right. Next one. Tell me if the sequence is arithmetic, geometric, or neither. So in this case, it looks like a times 2, times 2, times 2. That's geometric. Over here, it looks like a divide by 2, divided by 2, divided by 2. That's also geometric. Over here, it's add 1, add 2, add 3, add 5, whatever the previous two are, 5. So in this case, this is neither. Arithmetic has to be the same number every time. Geometric has to be the same number every time. Oh, over here, plus 3, plus 3, plus 3, plus 3. That's arithmetic. All right, next one, we're going to find the rules, okay? For the generic arithmetic sequence, an equals a1 plus d n minus 1. So in this case, it's going to be a1 is 75, 75 plus d, which is 8, times n minus 1. Guess what? That's your rule. Isn't that so useful? Now we're going to find it for the 20th step. So 75 plus 8 times 20, because you're supposed to put in 20 because it's 20 on the bottom, minus 1. And you could type that in your calculator. Do you need to see me type it into the calculator? No, you should be able to learn how to type in the calculator by now. Come on. 75 plus 8 times 19 is 227. So 227. Great job. Next one, the same thing. We're trying to figure out the pattern here, though. What's happening? Looks like I'm doing minus 4, so D is -4. The difference each time is -4. Over here, my A1 is my starting point. Looks like I started on 12. That's 12. So my formula is 12 minus 4 times n minus 1. So it's going to be, when I plug it in for 15, it's going to be 12 minus 4 times 15 minus 1. So 12 minus 4 times 14, which is going to be -44. How easy is that? Next one. What's the rule here? It's from 6 to 18, 18 to 30. Looks like I'm adding 12 each time. So D equals plus 12. My A1 is where I start, which is 6. So it's 6 plus 12 and minus 1. Guess what? That's 6 plus 12 times 13 minus 1. So that's going to be 12 times 12 plus 6. So 144 plus 6 is 152. So obvious. Next one. These are geometric sequences. I don't even waste my time to trick you. It just tells you it's a geometric sequence. The formula for a geometric sequence is a1 times r to the n minus 1 power. Make sure it's an exponent. So in this case, it's 1,000 times 1 half to the power of n minus 1. It's the fourth power. So 1,000 times 1 half to the third power. Zero point 0.5, because I don't have 1 half on my calculator, I'm using my phone, to the third power, then times that by 1,000. Whoa, looks like I made it purposely, so it's a whole number, like 125. Pretty easy. Next one, from 5 times what gives you 15? That's 3. 15 times what gives you 75? That's 5. I clearly made a mistake here. Pretend this is 45, so it works. So it's going to be where I'm multiplying each times by 3, and I'm starting, or and my starting point is going to be where I start, which A1 is going to be 5. So it's going to be 5 times 3 to some mystery power. What's the mystery power? N minus 1. In this case, it's 6. So 5 times 3 to the 6 minus 1, or 3 to the 5th power. So 3 times 3 times 3 times 3 times 3 times 5. So 1215. Funny how it's so close to the other number. In this case, what's happening? Looks like I'm dividing by 2, but how do I divide by 2? Well, I do 1 over 2. So 1 over 2 is my R, that's my starting point, or my ratio, and my A1 is 200. So A1's 200, R is a half, so oh wait, it's A6, so it's going to be 200 times 1 half to the power of the 6 minus 1, or power of 5. So 0.5 times 0.5 times 0.5 times 0.5 times 0.5 times 200. Luckily, that's not too bad. That's like 6.25. All right, next one. All right, find the following sum. So this is an arithmetic sequence, okay, where A1, or for sequence, so the formula is A1 plus AN divided by 2, all times how many times you're doing it, N. So in this case, it's going to be, N is 13, because I'm doing 13 steps. A1 is whenever I plug in 1 into the equation, so 5 times 1 minus 2, that's 3. And then AN, or A13 in this case, is going to be 5 times 13 minus 2. 5 times 13 is obviously 65, so that's going to be 63. So then I'm just going to plug it into my equation. 13 times 3 plus 63 over 2. 3 times 63. Oh, shoot. 3 plus 63 equals 66 times 13 divided by 2. That's going to be 429. Over here, it's always going to look like A1 times R. So it's pretty obvious that A1 equals 2 and R equals 3. But the formula for the sum of this thing is going to be A1 times 1 minus R to some N power over 1 minus R. In this case, it's going to be A1 2 times 1 minus the R 3 to the power 5 over 1 minus 3. So 1 minus 3 times 3 times 3 times 3 times 3 is 242 divided by 2, added 2, so it's going to be 242. Over here, this is an infinite sequence. In order for an infinite sequence, it's a pretty easy rule, A1 over 1 minus R. That's the rule for an infinite series. But you have to remember that D has to be less than 1, or in between negative 1 and 1. So people still can't understand that. I don't know what's wrong with you. But that's okay. I don't judge. So A1 is 12, and R is going to be 3 over 4. So in this case, I'm going to do 12 over 1 minus 3 over 4. That's going to be 12 over 1/4 equals 12 times 4, 48. So that's pretty easy. In this one, hopefully you realize, wait a second, 3 over 2. 3 over 2, that's 1.5. 1.5 is bigger than 1, so this is not doable. This is undefined, or actually I should say derivative. No, divergent. Cool. All right. Hopefully you don't mess that up. Next one, chapter 6. Is it weird that we did chapter 7 before chapter 6? Yes. All right, chapter 6. You probably didn't see this test if you haven't taken it yet. Please take your stupid test. So 6 exclamation point is the same as 6 times 5 times 4 times 3 times 2 times 1. So you got to type that in your calculator. Luckily, I know 5 times 4 times 3 times 2 is 120 times 6 would be 720. So 720. Over here, 9C4. So 9C4, you could type it into your calculator. You remember, you got to click math and then go right until you see prob, and then it's going to be like the fourth option. In this case, 9C4, I'm going to do it by hand, which is 9 times 8 times 7 times 6 over 4 times 3 times 2 times 1. Which way you do it, whether in the calculator, you go math prob and type it in, or you do it by hand, I just don't care. So you do whatever you want. So I'm going to reduce this to 1, reduce this to 2, because I don't have a real calculator with me. I just have my phone, so I got to do it this way. So that's 126. Over here, p times 7, that's going to be 10. Or again, you could do math probability. But to me, it's 9 times 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3. 1, 2, 3, 4, 5, 6, 7. Actually, no times 3. Good way. So then we're going to just times that in the calculator because I don't have the fancy calculator with me. So I could pull it up on the computer, but I just don't care. You should know how to use this on the calculator already. It's like the easiest section ever. If you failed this part, whatever. All right, how many ways you could order the letters in the word Kushner? You look carefully. Kushner has no repeated letters, so it's 1, 2, 3, 4, 5, 6, 7. It's 7 factorial. So 7 factorial, 7 times 6 times 5 times 4 times 3 times 2 times 1. So that's going to be 720 times 7 is 5040. In this case, you're going to do this one, which is excellence, which is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there's 10 letters, but the problem is I have 1, 2, 3, 4 E's, so that needs to be divided by 4 exclamation point. And then I have 2 L's, so that needs to be divided by 2 exclamation points. And I have 2 C's, so that also has to be divided by 2 exclamation point. Remember to put this in parentheses so you don't mess up. Again, I'll just do it here. So it's going to be math. Or sorry, first you should type in the number. So you're going to go, okay, come on, buddy. So we're going to go 10 exclamation point. And then math, go over here, exclamation point. That's option 4. And I think maybe, is there a button that lets you do exclamation point here directly? No. Okay, so 10 exclamation point divided by, put in parentheses so you don't mess up, 4 math exclamation point times 2 exclamation point times 2 exclamation point. But hopefully your brains could understand 2 exclamation point is 2 times 1, which is just 2. So don't waste your time putting 2 exclamation point. So 37800. 37800. How easy is that? All right, Bill has 10 shoes, 8 shirts, 6 pants. I feel like you learned this in middle school. So 10 times 8 times 6, that's pretty easy. That's 480. There's nothing special about that. Over here, you have a 5-digit code. Well, you have 10 options on the first digit. There's 10 options on the second digit, 0 to 9. 10 options on the third digit, 4 options on the 10. Let me restart. You have 10 options on the first digit. Then you have 10 options on the second digit, 10 options on the third digit, 10 options on the fourth digit. Say this 5 times 5, whatever. 10 times, whatever, man. It's 10 to the 5th power, which is 1, 2, 3, 4, 5, 0. So 100. So there's 100 different numbers you can make. All right, in this license plate, you have 2 letters, so 26 times 26, because there's 26 letters. If you ask me how many letters are in the alphabet during the final, I just won't respond to you. This is a shame. And times 10 times 10 times 10, and I'm going to do 26 times 26 times 10 times 10 times 10 is 676,000. A teacher who needs to pick up 4 students out of 15 in order to represent the school, how many ways can she make the team? There's no indication I care about order, so it's 15C4. You know how to put in the calculator. I'll show you once because I'm not going to do this a bunch of times. So it's going to be 15, click math, go over to probability. Hey, NCR, it's literally what you're looking for. And then you're going to type in 4, press the enter. Wow, 1365, isn't that easy? All right, next one. A student council needs a president, vice president, and treasury. Those are different jobs. We're being particular. There's 10 people in total, so it's 10P3. Yeah, you always got to pick the bigger number in front, duh. Because how else are you going to do it? So 10 times 9 times 8. That's 720, I think. So Jim is flipping a coin 10 times. What's the probability he gets exactly 7 hails? So you need to do the formula. The formula is going to be how many times I'm doing it, 10. C, how many times I'm going to win, 7. Probability of me winning, that's 0.5 or 1/2. What's the how many times I'm going to win, 7. Times how many times I'm going to lose, 0.5. Times how many times I'm going to lose, 3. So in this case, it's going to be 10C3. I'm just going to leave that to you, plug it in. I'm not going to waste my time. Over here, I got 5 questions. I want to get 3 right. So 5C3. It's a multiple choice with A, B, C, D. You're about to experience this situation. So 0.25 or 1/4. And I want to get 3 of them right, which means I have a 75% to get the 2 wrong. Type that in your calculator. As a survey about 200 people, what's the margin of error? I don't know what's wrong with people. This was an easy ass question. You should be able to do this. This is 1 over the square root of 200. Lucky for me, the square root of 200 is something not basic, actually, so I can't do that in my head. So 1 divided by the square root of 200 is going to be 0.0707. Guess what, buddy? This is a percentage, so it's 7%, 7.07%. All right, I want the margin error 8%. So this one I also am shocked people couldn't handle because it's just like straight up algebra. It's just algebra. Like, why can't you do this? It's 8%, but I can't use 8% because I'm doing math. So it's going to be 0.08. So I need to get n on the other side. So I'm going to do 1 equals 0.08 square root of n. I'm going to divide 0.08 on both sides. 1 divided by 0.08 equals the square root of n. Oh, there's a square root. I'm going to have to square both sides. So my answer is 1 over 0.08 squared equals n. Again, I can't understand why people got this wrong. But, I'm just tired. I'm just speaking my mind. You know all that. So that times 0.08. I end up getting 156.25. You can't ask 0.25 of a person, so it's 157. That should have been your answer. For this one, you go to surveys 570 teachers or teenagers, 34% says their favorite way. So it's going to be 34% or 0.34 plus or minus 1 over the square root of 517. So you got to do the square root of 517. So 1 divided by the square root of 517 is about it's going to be 0.043. So I'm going to add 0.403. I'm going to minus 0.043. So that's going to be 0.383 or 0.297. Then we just change it to percentage. So 38.3% over 29.7%. It's so obvious. Next one. Rabbi Rubin wants people to think about the school. He breaks it into groups and asks 15 person per group. He asks them, what do you think about the school? What's the problem, or what's the sampling method? Stratified. Stratified is grouping. Random is just random. You don't know what the word random is, you have bigger problems in life. And systematic. Systematic means there's some kind of rule that's evolved. I pick every third person. Every second person with a last name that starts with T comes by. There's some rule. What makes this sampling bias? Well, if you could read, you could see that it's Rabbi Rubin asking you. So if you mention something like Rabbi Rubin is asking directly, because his question is, what do you think about the school? Will that give him a direct answer of what people actually think about the school when he asks you face to face? No. So how does Rabbi Rubin fix this? He does it anonymously, like a survey, or he asks somebody else to tell him, or he puts out a survey, like a piece of paper you fill out that you could privately do it. There's a lot of ways you could fix it. I'm not going to go over every way. That's the last two tests. Good luck, buddy.